All right. So today we are going to talk about the web a little bit and understand how data gets to your browser, basically, how you can see the websites that you see when they happen. We're going to understand the basics of HTTP. HTTP is a web protocol. We'll dive into the details of that in a bit. We're going to understand what an API is, and then we're going to learn how to send API requests to servers to get data, and it'll all hopefully make sense. Okay. So before we can dive into what HTTP is specifically, we want to understand how the web works a little bit more at least. So there are strict rules of about how applications can communicate with each other over the internet, and these rules are typically called a protocol. Communication on the web is not defined by one protocol, but it's basically a stack of protocols on top of each other. So we're gonna first talk about a few buzzwords, a few words that you will hear. So IP, does anyone know what IP stands for?
Internet Protocol.
Yeah, so Internet Protocol. So Internet Protocol IP is the first one that you should know about. So the Internet Protocol is basically concerned with where a server is located on the internet. So each, and a server is basically just a computer, right? So each computer that is attached to the internet has something called an IP address. So that an Internet Protocol address. So IP addresses, forgot I had my caps lock on. But on an IP address, let me give you an example of what one would look like. So it's typically like 3 numbers, followed by 1 or 2, or yeah. So the ones afterwards can be different ones. But yeah, like this is what an IP address would look like, and this will tell us the address of where a computer is on the internet. So think of it as like an actual house address. It allows you to figure out the general location of the server. So yeah, so an IP address is a series of 4 numbers that are separated by periods. Whenever you type a domain name into your browser, it is converted into basically an IP address, and that's how our browser knows where to make the requests to. This format of IP address is called IP version 4. There's an IP version 6. IP 6, and it's basically just longer. I wanted to show you just an example of what it looks like. Yeah, so there's much more. There's 2, 2, 3, 4. Yeah, so there's 8 numbers basically, and they're hexadecimal. So you can have actual letters, and it's more precise, I believe, because you can represent more addresses with IPv6 than IPv4. But yeah, so an IP address is basically just an address for the computer. So if I type here, google.com, and I hit enter. How does my browser know where Google is and how to grab this page from them? So our browser first looks at the domain. So our domain is going to be whatever it is, so google.com, that is our domain. Then it is going to use something called a DNS server, sorry, just DNS. So let me write that out. So DNS stands for, does anyone know?
You said DNS, domain
Name server.
Yeah, so domain name, it's either server or systems. I've heard systems, system. So basically DNS is a collection of servers that has, that knows where address it, like basically maps an address to a domain name. So we can ask a domain name system, where is google.com, and it'll give us the IP address for google.com. So DNS basically gives us the IP address of where the domain name server is located. Okay, so why do we need to know the IP address? Why can't we just say, like, give me, like we have google.com and be like, yeah, let's go to Google. How do we do that? So we need this IP address because there is another protocol in the internet that that governs the connection between two servers. So we are the client technically because we are asking for the data, and the server is the backend. So we're asking, we want to make a connection with that server and grab data from them and make requests. So the protocol that governs this interaction is called TCP. Does anyone know what TCP stands for?
Transmission Control Protocol.
Yeah, so Transmission Control Protocol. So TCP is a bunch of rules on how to get on like connecting, how the connection happens basically. It provides a reliable, ordered error check delivery stream between the host and the server and the client. And it is a little bit slower because it has to generate a connection and make sure everything is good. But basically, it's a reliable way of connecting to another computer and making requests that way. So typically what happens with a TCP connection, so with this protocol, it takes an IP address, it takes like a port number if you provide it with it, it takes the data that we need, and then it sends it over. It sends it all the way over to the server with that IP. So it uses this IP to find that server. So this is my server. So the first communication it makes, it sends a SYN connection. So this is for synchronization, or synchronize. And then the server will see that. Oops. Just getting my formatting over here. Okay, so the server will then to do this. Okay. Just want it to look pretty. So the server will then take that, what is it called? That synchronized request and send back a SYN ACK, which basically is saying like the synchronization is acknowledged. So it sends it back to our client. I know this is very not pretty, but hold on. Bear with me, guys. Okay. This isn't working well, but this is our client. Okay. So yeah, it basically sends it back to our client, saying that we've acknowledged, the server says, I have acknowledged this connection. And then the last bit that it sends back, I forgot what the name of it is, but it's like a final acknowledgement. Basically, like, okay, we have now established a session. I believe with the last thing that it sends over like a session ID. Actually, no, I think the server sends a session ID. So the client is like, okay, now we've established a connection. So let me look it up actually. TCP and server. Oops, not video. Is it this? No. Okay. Oh, maybe this one. Yeah, so it's called a three-way handshake. Basically, there's a synchronized. So this is host A is going to be like us, our client, the client, and then host B is the computer that we're trying to reach. So it sends a SYN, and then it sends back a SYN ACK. So it acknowledges the synchronization. It sends like a sequence number and a bunch of information, and then once the client receives that, then it sends an acknowledgement and a sequence number, and then basically establishing the connection. I guess they didn't put an actual name here, so this was not that helpful, but that's typically how that's the TCP protocol. So TCP is a bunch of rules that say if you want to make a connection with a computer, you have to have this three-way handshake to make sure that the connection is good, and then you can make your requests to the computer. So after this TCP connection has been established, you can then send HTTP requests. Because you've already established the connection. So going back, each computer has an IP address. When we type a domain name into the browser, it uses the domain name system, which is a bunch of servers that has information on which domain name has which IP address. It gives us the IP address, or it gives the browser the IP address. The browser then makes a connection with that, with the server at that IP address using TCP. So it makes the three-way handshake, and then it makes a request to, let's say if we're doing to google.com, then it says, can I get google.com? And then the server will respond with the actual HTML page. So the client says, get google.com, and then the server will respond with the HTML page that it needs. And then when it's loading the HTML page, if there are more resources, so like in the HTML page, if there's a style sheet that was in there, then it notices, okay, I have to get the style sheet. So it's going to make another request back to Google or wherever that style sheet is and says like, okay, can you give me the style sheet? And then it keeps going back and forth until your page is complete. And this is just like an overview or a high level understanding of how the page gets to your browser. But yeah, oh, I missed the chat. I'm sorry, guys. Yeah, so the final one is an ACK. Thank you, Jose and Brandon. Any questions? Yeah, completely forgot about Excalibur. That would have really helped. Would anyone want to see this drawn out that way again?
I had a question. Which server is going to be giving the HTML page? Is it the DNS server or?
No, it's the server that server at IP address. So yeah, let me redraw it in Excalibur. That's actually a better way. Let me clear. Okay, so we have our client, and then we have our server. So we typically say server is whatever computer is serving us the data. So that's just a general term. Sometimes servers are regular computers. Sometimes, a lot of times they are specialized computers called servers that don't really have like a computer. They don't have like a monitor and keyboard and mouse and stuff, but it's just the piece of hardware that holds the data, which we'll play around with that more afterwards. Okay, so in our client, this is our browser, let's say. So we go to google.com. Client, oops. Say this is the client browser. So our browser is just a program that does things. So all of this is just a program that someone wrote. When I type something in here and I hit enter, the program does stuff in the background. So remember that. So yeah, let's say this is my top bar in my browser. I go to google.com. My browser will then, so step one. Step one is going to be DNS lookup. So our browser is going to consult the DNS servers and look up google.com to get an IP address. So DNS lookup takes domain name and gives an IP address. Okay, so this is step one. And then when we have an IP address, we start a connection using TCP. So our first bit of connection will go here. So this will use IP address. We start connection with server. So. Oops. Okay, so we use the IP address to make a connection with server. It does like a couple back and forths. So this is all number 2. Use the IP address to make connection. Once it is then connected, so this is my final acknowledgement. Then we send our request. This request is going to be in the form of an HTTP request. So HTTP request. And then finally, okay, these are getting a little too crowded. Move these up. Okay, so 3 is the request, and then 4, we have HTTP response. And this response will hold our page pretty much, or whatever data that we're requesting from the server. So HTTP is a protocol that determines like what is being sent over, like the actual data. So all of this, like the TCP stuff, TCP is only worried about how you're establishing the connection, whereas HTTP is concerned with what data actually gets requested and sent back. Yeah, Nmap for port discovery. Yeah, try not to hack into things. Writing the stylus sheet.
That's the HTML hacker.
Yeah. People don't know that. It hasn't been proven. DNS is kind of a big phone book. Yes, exactly. So DNS is basically a big phone book for lookups. So you can look up google.com. Let me show you how you can do it. You can do it from the terminal. So actually the DNS servers, or like DNS in general, because it's a very common occurring thing that that browsers have to do a lot, and computers in general, they have to find where to make the connections. So this is very like highly cached. So your browser holds on to some of the DNS information. So if you've been to the website before, you don't actually have to go to the DNS servers. The browser already holds like where that IP address is. And then the second layer is your computer. So your operating system holds on to DNS information as well. And then if it doesn't find it in the browser or in the computer, then it will go out to the internet and find the IP address using the DNS servers. DNS lookup in terminal. I forgot which command. NSLOOKUP. Okay, let me open terminal and see if we can do this. Oops, I think this stuff is cool. So NSLOOKUP, I'm gonna say google.com first. And it gave me an address. Give me another website, something maybe far. Like in a different, like something that's not that used.
AliExpress.
Let's do it. Is it express.com?
Yeah.
Okay. Express.com. There we go. So they have 2 IP addresses for them. Diz.biz, is that an actual website?
It's his portfolio, I think.
There we go. Let me try. I don't know if this is a thing. Yeah, so localhost, you've seen like the 127.0.0.1. So localhost is technically a domain name, and then this is the address. And it just refers to your current location. Yeah, let me try this last one. National Geographic. So NS lookup, oops. I copied the wrong thing. So the server can't find it because it's looking it up with the HTTPS. So we'll talk about this in a bit, but this part does not need to go into the DNS server. All it needs to know is the actual domain. So let's go back and erase that. It's possible that we have that. There we go. So it just needs the bare domain, and yeah, National Geographic has a bunch. So this is like the main facing them, one canonical name with like internally they use this, and these are their servers. So sometimes the bigger companies have a server that has its own lookup, and it kind of like reroutes certain requests to different servers based on what the request is. But yeah, any questions about this? Did I miss anyone's question or comment in the chat? Okay. So Diz, you mentioned UDP. So UDP is another type of protocol for the internet. It's faster, but less reliable. So basically with UDP, all you need is the like IP port and the data, and you kind of just like throw it out there. You don't care about sequencing, but with TCP, you have first of all the three-way handshake that establishes like a good connection, and then each packet of data. So the data is big, so it sends it in little packets. Each little packet of data has a sequence number and a like I forgot what it was called, like, but it's like a quality check number basically. So it makes sure that there was no data loss. You basically get all of your data back and forth. Yeah, okay.
If you wanted to host your own server, would you have to like go get, I guess, like a domain name first and then somehow like use your local host to host your own stuff? Like, how does that work?
Like host your own server at home, right?
Yeah, so like when you looked up localhost, you was just only able to get localhost, but like other people aren't able to access localhost. But if you want to do something, you know.
Yeah, I think you would have to, so you can buy domain names and then you would attach that domain name to a server IP address, basically. So like when you buy domain names, like, I don't know, there's a bunch of websites like domains.google. In your domains, like I have this website, but basically you can, so you can set the DNS and you can set what the record is and where the data goes to like which IP address basically.
But you want to talk to your ISP before you use your own IP address to host a server. A lot of ISPs won't actually let you do that. And if they see that kind of traffic, they'll shut down your internet.
That makes sense. That's why I was kind of curious, like, how does that work? So it's the IP, it's the internet service provider is giving you that IP address, and then you route it.
Yeah,
Yeah, you're basically putting your address out there for other people to communicate with.
yeah, that's a good point, Dave. Thank you. Other questions? Is that where the cloud comes from? Yes. So the cloud itself is not something like it's not something magical or nebulous. The cloud is just a bunch of servers. So this server, each server has an address, and then that's where like network connections know how to get data from things in the cloud. The cloud, everything in the cloud has its own address as well. So yeah, that's yeah. Unless you were talking about the ISPs and figuring out the IP addresses and stuff like that. Yeah, when you're using a cloud, it just handles everything for you. It gives you an IP address automatically that you can use. Bottom line is the internet runs on magic. It's very funny. It does seem magical, but it's actually not that bad. It's just a bunch of rules and ways that people communicate. And these protocols and rules are there to make sure like everyone is communicating in the same way, and everyone knows if they want to communicate with someone, make a connection, that they will be able to do so in a reliable manner. But yeah, now let's talk a little bit about HTTP. So like I mentioned, HTTP is the web's protocol. So if you're making regular connections with, if you want to get web data, HTTP is going to be the protocol that you use. You guys can see my screen still when I presented? Yeah, okay, cool. Awesome. So HTTP stands for Hypertext Transfer Protocol. So the protocol was originally described in 1991 with the origins of hypertext. So basically, old internet was just a bunch of text and links. And those links led to other pages of text and more links. That is how the internet is connected pretty much. So hypertext, the HTTP protocol was originally designed as a protocol for transmitting hypertext, and the modern equivalent of that is HTML. So we use HTML, and it has grown to support much more than just linking from one page to another. So now we have like images and videos, and there's all the little components that you guys have been playing around with this week, that you can add into HTML to make the websites come alive, and be more interactive. And JavaScript added even more because now you can interact to another degree. HTTP has also found new use cases. So while transmitting HTML is a common use case, HTTP can be used to transfer any type of document or file. So you can make HTTP requests to not just get HTML files, but you can also do it to get data, which is what we do in APIs. So today, HTML isn't even the most common type of document that's transferred over HTTP. So you have images, CSS, JavaScript, API responses, and yeah, those are far more common. Okay, so we saw something similar. So the client and server conversation. So this is after the connection has been established. You will have a request and then a response. So an HTTP request, then you get a response back. And both HTTP requests and responses are in plain text, so you can just read them off the internet. Like if you just see what the request is and see what the response is, it's very easy to understand what it's trying to do in most cases. So this is what they would look like. So a request, you have your first bit here, which is your request line. So yeah, we'll talk about the request. This is generally what it looks like. You have a request up here, which host you're trying to call. And then this is typically filled in by the browser itself, because this is just saying what agent it's using, which is Google Chrome. And then you get a response, which we'll dive into in a bit. So in the request, you have three main things. So you have a method. There are a few different methods that you can use in HTTP requests. So for this one, we have a get method. So we are trying to get information. You have a URI, which is basically the part after the .com, the part after your main domain name. That is called a URI. It's I forget what it stands for. We'll see it in another slide. But yeah, URI is what is it called? Let me see real quick. Okay, never mind. But yeah, so the URI is going to be the resource part, so the part after the slash. So example.com/bio.html. So this is what resource we're trying to retrieve. And then at the end, it's the protocol version. For this one, it's just HTTP/101. Thank you, or you deleted it, uniform resource identifier. So this is the resource that we're trying to get from this computer or this domain, basically. But yeah, so in the request part, so this method, there are a few different methods that are commonly used. You have get, which is commonly known to retrieve a resource. Post is send a resource, and typically when you're using an API, which we'll talk about that a little bit more, you can send data to that server to typically like save the data. So if you're creating a new resource, like you're creating a new customer or something like that, you would use a post request, put your data that you want to send to the server, and then send it. Put requests are typically for updating a resource, and then delete is for deleting a resource. So even though this is like the common way of using these, it is always up to the developer to enforce this. So we are going to be making our own APIs later on, and we're going to be handling these requests. So it is up to us to handle it in the right way. So if it's a get, we should only allow sending back data, like we should only allow this functionality, although you can technically do anything. Yeah, here it is. So URI stands for Uniform Resource Identifier. And this is the part, like I said, where it's after the slash of the URL. So if we looked at, yeah, you guys know, we'll see a different example. Okay, so URL. So, okay, yeah, URI is going to be this part of the URL. URN is going to be the host and the URI together. I don't really remember what the N stands for. Probably Oh, resource, uniform resource name. So this is the entire like URL or URN. And then URL is the host and the URI plus the protocol. So plus what are we using as our protocol for security? Or sorry, as our protocol in general. And our protocol here is HTTP. So we're using HTTP to go to this website or to go to wherever this server is hosted and retrieve this HTML file. In most browsers now, you will see HTTPS. HTTPS is just HTTP with security. So what is it called? It encrypts the data that's going to be sent over. And there's typically like a certificate. We'll learn more when we're deploying our websites. But yeah, oops, but next. Okay, so we talked about the request line, and you typically don't have to actually write the request like this, but this is what it looks like in its purest form. So there's an actual request line, and then there's another part to the request, which are headers. If you've looked in the network tab, which we'll do in a bit, you can see that each request will have headers. And in these headers, like here, host is set to the host that we want. User agent is set to the browser that we're calling from. So typically, this is for requests that don't include a body. So if you're thinking of like how HTML pages have like a head and a body, HTTP requests are kind of similar. So they have headers and they also have body in some situations. So if we go back to this, get is not going to have a body because you're just requesting some information, but you don't need to send data to that server. Whereas post and put, you're typically sending something. So you want to send something to create a resource or send something to update. So that means that you will need to send data in the body. So the body is optional. Request bodies are, most commonly included with post, put, patch, and delete. We didn't really talk about patch, but patch is, I think, updating only partially. It's not that commonly used. Typically, people just use put for updating things. But yeah, so they can include any type of content. So this could be an image, it could be form. So it could be like a query with variables. It could be JSON. It could be anything. Okay. Yeah, so query parameters. So if we look at a website, let me exit out of this. Let me see, this is perfect, okay. So if we look at this address bar, I can't make it bigger, okay. We see that it's using HTTPS as its protocol. It's going to google.com as the domain. And then it's going to call search. This is the URI, basically. So if we look back here, this is the same example. But yeah, this is the URI. And everything afterwards, sorry, I needed to go back. Okay, so with a request, you can send parameters. So here, Q is the variable name, and then this is the value. So after the equal sign, that's the value. So Q is going to be what the query is, I guess, for the search functionality. And then TCP plus client plus server just means Like the pluses are the spaces between. So it's just like these 3 words. And then if you want to add another variable or another parameter, then you put an and then the next parameter is called client. And then, whoops. The next variable is called client. And our client here is going to be Firefox. The next one is this, whatever, TBM, whatever it is. These are probably all internal. So every single one between the ands is a key value pair, which is a parameter that goes to the server. So that's one way to send parameters or just send parameters into a request. So yeah, let's go back here. There we go. So you can add additional data as part of the request in the parameter. So it will go as part of the URI instead of being inside the body. Query parameters are separated with the question mark, like I said, are separated from the URI with a question mark. So you have your URI, you have a question mark, and then you start putting your parameters, and then separate the parameters themselves. You have the ampersand here. Any questions? I've kind of been going quick. I should pause. Okay. Yeah, so you could either so like with the GET request, you're not sending a body, but you can still send parameters pretty much to specify certain like filtering or functionality that this will make happen. Okay, so the request headers we touched on a little bit. So here are some examples. They pretty much just provide additional context about the request. So like I said, the host tells the web server which domain the client is requesting the content from. Often a single web server will serve content from multiple domains. And the server users uses, that's a mistake, this header to determine which content to serve. So basically, multiple servers can be on the same IP address. So the DNS part makes a connection with that server, but it needs to know still within that server which exact domain to hit, which specific host that we're trying to get data from. Accept language. This is to let the server know which languages it prefers. User agent is which type of client is making the request. Accept is what kind of data we're going to accept from the server. So you can set text/HTML, text/plain. It could be basically you have to you can specify what type of response you would like. You can specify JSON, you can specify an image. Okay, so that was all about the request. You send the request to the server. What does it give you back? So it gives you first, so this is the response. It will give you a status line saying the protocol that it used, the status code, and what the status code means. It also sends back some headers. So we see in the headers here, we have content length, which says how much, what the length of the body is, the date that it was sent, and the content type. So what type of data is sent back. And then it also sends back the body sometimes. So it depends on the type of request, and it depends on if there was an error or if it was successful or not. Okay, so the response status line has the status code and then the reason phrase. So there are a bunch of codes that have been agreed upon to use in certain situations. So 200 is okay. 302 is a redirect. see other, so it sends back like, see this other website. 400 is a bad request. Oops, 400 is bad request. That means I cannot process your request. This doesn't make sense. 401 unauthorized, that means you do not have the credentials to get this information. 404, which we've all seen, not found, means I can't make, there is no URI that you're trying to request, or there's no resource that you're trying to request here. And then 500 is an internal server error, which is very general. You typically want to handle your server errors in a better way. But yeah, the response also has, actually, before we go into the headers, let me show you some other response codes. So there's ranges. So the 200s are successful responses, 300s are redirection, 400s are client error. So basically the client sent a request that doesn't make sense to the server. 500s is the server error responses. So yeah, you can read these. Let's see if there's any other ones that are important to mention. 201 created, this is a decent, like pretty common one. Accepted. You might see a 304 sometimes. So your browser may hold on to the website that you've been to for caching purposes, just so it doesn't have to go back to get the request. So if the response is a 304, that means the server didn't send a new version, you already have one. Let's see, permanent redirect. This is if you, the resource is now permanently located in another URI and stuff like that. Bad requests, unauthorized, we talked about that. Forbidden, method not allowed. There is URI too long, doesn't request it. This one is funny. 418, I'm a teapot. The server refuses the attempt to brew coffee with a teapot. This was added in as like an April Fool's joke some year. But yeah, so there's a bunch of important ones. Yeah. That's all I'm going to say about that. So the headers that we get back typically say what the content type is, the length. There's a set cookie header that is common. So if so cookies are basically pieces of information that your browser holds on to for ease of communication between your computer and the server that you're communicating with. So a lot of times you'll have like a session ID, so that's in your cookies. So that's how, like if you're on Amazon and you're browsing and you're adding stuff to the cart and you close out the tab and then you open another tab, your cookies are saved. So it'll know that it'll basically show you where you left off. Well, yeah, Amazon might be using some other thing, but cookies are typically used for that. And cookies can be seen from the browser. So that's why they sometimes are a bit of a security risk if, like, depending on what kind of data is being pulled, or if someone gets control of your browser, they can see all the cookies and stuff like that. Yeah, so the server, when it sends back a response, it could tell you to set cookies. And for this one that it wants to set, it's setting a currency cookie. So cookies are just key value pairs. So currency equals US dollar, stuff like that. And then date is also a common response header. But yeah, so there are many HTTP conversations that are happening when you load up a page. So you're browsing a few pages on a typical website, dozens or hundreds of HTTP conversations will take place within just your one website browsing. So you'll initially load the home page, so HTML, so just one HTTP request and response. But then when that HTML is starting to render, you'll start loading CSS and JavaScript and images and stuff like that. So it'll continue adding on to the requests that are there. HTTP requests are stateless. So it's a very important characteristic. So basically, every conversation, it doesn't share a state with the previous conversation. So every time you're requesting a data, it's something, and you're getting a response, and that's it. If the next request has nothing to do with the previous request. So every HTTP conversation begins with a new connection from the client to the server. It's as if the two parties are meeting for the first time. Even requests made just moments before have no bearing on the current request. So most servers clear all of their state or the variables with each request. So that means all state when processing a request come from the request itself. So one thing that is kind of like a workaround to the statelessness is the cookies that we just mentioned. So cookies help retain state, like who's logged in or what was their last search, and stuff like that across multiple requests. So basically, if your browser is holding on to certain cookies and you send a request again, those cookies are going to be attached to the header of the request. So the server will know the context based on the cookies. So yeah, HTTP as a protocol remains stateless, but it depends how it uses the cookies and stuff like that, that there's a possibility of continuation within the state of it.
I got a question about these. Oh, sorry. I was going to ask about the cookies, but it looks like you're about to go in more in detail about the cookies. Sorry.
Do you want? Yeah, I'll go through it and then you can ask your question. Yeah, so we'll learn more about cookies later on. I think week 8, 9, maybe before 7. But yeah, so the server sets the cookies by sending them to the client as part of the response. And then the client stores the cookies, typically in the browser. And then the server does not store any cookies at all. Any cookies for the current domain are sent as part of the request. So if this is the first time you've ever sent a request to that server, you won't have any cookies. But if you have, and there's cookies accumulated, then yeah. So if you're ever on a website and you're having trouble with logging into multiple accounts and you try to I don't know if anyone has had this issue, but you have 2 accounts and it keeps logging you into the one, even though you hit log out and then you open a new tab, it's still holding onto the cookies. So sometimes it doesn't recognize that you've logged out or you're trying to log in with a new account. So that's when you can just clear your cookies in the browser, which I'll show you guys in a bit. And then it would be like a new request, a fresh request. But yeah, Angel, you were asking, you wanted to ask a question?
No, I think you're kind of hitting on it right now. Like basically cookies just store information about you. And then when you go into the website that gave you the cookies, they're able to read certain information and hopefully it's not too in depth. I guess cookies, because I think cookies also slow down your connection to the website, or it makes things slower.
I'm not sure about the slowness part, but I do know that so when you're making a request or any request to that website again, or to that server again, it's gonna send all the cookies with it, like you said.
Okay.
But yeah, I'm not sure about the
You
slowness.
have about half of a jillion advertising cookies on your computer right now.
That probably, not probably, most certainly. Ads are evil. Yeah, any other questions or thoughts? Okay. So yeah, in summary, HTTP is, I know we're talking about HTTP now in all browsers, it's HTTPS. I think, yeah, like try not to go to any website that has only HTTP. HTTPS is more secure. But it's basically HTTP plus security on top of it. But yeah, it's extensible and we can use it for making a bunch of different requests that give us data in different forms. Yeah, that's the end of the slideshow. Do we have any questions about this?
In an interview, how in-depth would we be, like, questioned about things like this? Because I know that they would ask like simple questions like what is HTTPS or something, but yeah.
It depends on the type of job that you're getting. I feel like if it's more of a networking type job, like networks and understanding the connectedness of everything, then they would care about knowing what TCP is and like how all that stuff works. This is more for like the understanding of what happens when I make a request. Like how is the back and forth going? I personally haven't gotten any questions about that, but also I wasn't looking for web type jobs. So I'm not sure how in depth, but I don't imagine like this in depth, just understanding that there is a request sent, response sent back. Cookies typically hold information that allow the server to like remember you in a way. And yeah, that like HTTP requests have different methods. They have headers that you can set. There's like stuff like that. And this is a lot of like practical stuff, or not practical stuff, but a lot of theory stuff. So we'll see how we can actually apply it. We're going to make some HTTP requests.
Yeah, technical. Thank you. I appreciate it.
Of course. Any other questions? Okay. Last thing I want to mention before we go to our go on a little break. So every time you hit enter up here, if it's a website or if it's so not when you're searching. I know browsers now have like if you just type something, you can hit enter and it'll go to a search page. But if you actually have like a website with like / something something, that is going to make a GET request. So anything you put in the browser makes a GET request. That is the basic thing that you have to remember. So if you open your terminal in whatever website you're in and go to the network tab, it might not see anything. You might not see anything here, but refresh. And these are all the requests that are made to show you this website right now. So our first request was a GET request. It was made to this domain, Excalibur. The file, so the resource, the URI was just the basic / because there's nothing afterwards. And yeah, so it sent back an HTML document. If you click on it, it'll actually show you what headers were in there. So these are the headers of, this is the GET request. These are the headers, sorry, not the headers. These are the headers. No, these are not. request headers down here. Sorry, guys. But yeah, so it shows you what was sent with the request. So accept, this is what document types it will accept. Encoding, connection, host, stuff like that. So this is what my browser sent over with the request to Excalidraw here. And then as a response, it sent back a bunch of headers here, which we won't really go into a lot. But yeah, this is where you can see your headers. Cookies, I don't have any cookies set for this website, so there are no, or sorry, for this request, so it doesn't matter, no cookies here. No payload for this request, so that means there's no data in the body of the request. And then you can look at the response. This is an HTML document. It says you need to enable JavaScript to run this app. This is probably done with what we saw it the other day.
I think it was no script. Like a
Yeah,
tag.
yeah, a no script tag, exactly. But if you see just the raw HTML, you can view it here. And this HTML is then shown in your main browser window. But you saw it wasn't just this one request, it was a bunch of requests. So what is this? Google tag manager. So something with Google. It got some fonts.css, so a style sheet was sent back, a JavaScript file. So this is what we requested basically. JavaScript file, another CSS and stuff like that. So these are all resources that make the entire website function, but it all started from this initial one.
I got a question.
Yeah.
Can you check out this website, theverge.com? It's like a tech blog. So when I checked it out, it gives me like 1 billion GET requests. And I was kind of curious, like, why is it so many requests?
This one?
It's probably communicating with all the different ad servers and stuff.
It just keep going with like network requests. And I'm like, what is all this?
So all of these here, yeah. So let's see.
The Shell Corporation. It's running crypto in the background.
Yeah, so on mine, I don't know why. Like yours looks like it stopped at 27 requests, but mine just kept going and going and going.
Interesting. Am I not? I don't know what this means. Did you go to just the basic page?
Yeah, the same one that you're on.
Let me try doing this on Google Chrome. Are you on Firefox or Chrome?
Firefox.
Oh, okay. So we are on the same one. That's weird. Do you want to share your screen? I would be interested to see. Like, so
Yeah, I can share.
Yeah. Let me stop sharing real quick. Yeah, some of these requests, I'm looking at the ones that I see. Some of them are just assets, so a lot of them are probably images and stuff related to the JavaScript files that are running this website. Some of them are like Google services. This one's Google Optimize. Yeah.
I think I'm on mute again.
Yeah.
Are you able to see like all of these requests?
Yeah, I can see it. I can also see.
It's kind of like it said 512. I don't know why.
Oh, damn. So scroll down and see what is it exactly. So what was the website?
The Verge. I think it's something wrong with maybe like my browser settings or something.
Can you do disable cache or something? Because it seems like everything keeps like refreshing and caching and then reloading.
Oh yeah, because like even looking at my browser, it just keeps look like it was refreshing, but I guess it stopped now. Maybe it's some. Oh, it did stop. It looks like. Oh no, 12.
Huh.
I don't know. It's weird.
That is very weird.
You found a bug.
Yeah,
I don't know. Doesn't seem like it's intended.
probably not. That's wild. Yeah, any last questions before we take a break?
Yeah, I have a question, but I don't know if it's like too far outside of the scope here, but how does all this gets and requests and stuff, how does that work in not a browser environment? Because the browser, obviously, it's using HTTP. I get that, but what
Yeah.
about like a something else that uses internet that isn't a browser, a game or like Spotify app or Netflix? I
Yeah.
mean,
So you can make these requests from code, which we'll see in a bit. So JavaScript has a built-in like fetch function that will allow you to make requests. We'll use more this library called Axios because it makes things like it makes the requests a little simpler. But basically, you can make all of these requests from JavaScript, from Python, from different languages, and that's how typically it's going to be done within.
okay. Okay, that makes sense.
Great question, though.
Thanks.
Yeah. Other questions? All right.